Hello. So today we're going to discuss the volume of rotation and the washer method. So this is still on chapter 6, section 2, part 2. Part 1 was basically the volume of rotation and the disk method. Now this time we're discussing the washer method. So case 1. So first we have a region that is described by all the data. We have y equals f of x, y equals u of x equals a, x equals b. The assumption is that f of x is greater than g of x and greater than k, some number, positive number, and a is always less than b. The rotation is about the line y equals k. And the question is to find the volume of rotation. So let's discuss case step 1. Step 1 is to graph the region. So here's the region. We know f of x is greater than g of x. So y equals f of x, that's this curve. And below it you have y equals g of x. And on the left side you have x equals a. On the right side you have x equals b. And then below the region you have the line of rotation y equals k. And then below y, the line y equals k, you have the x-axis. So you create this region. This is the region that they give us, the shaded region. And the line of rotation is y equals k. We mark those curved arrow. So now you're going to take this region, you're going to revolve it 360 degrees with respect to this line y equals k. Now, so let's just talk about the difference between the disk method and the washer method. Now, you cannot use the disk method to solve the washer method problem. The reason that this is different from a disk is that between the line of rotation, as you see here, and the region, there's an empty space. You can see this space here is empty. Whereas when we discuss the disk method, the line of rotation is always part of the region. So it's one of the side of the region. It's all connected to touch each other. But with the case of the washer method, there's a space here, empty space. Sometimes the region does not even touch the line of rotation. So then you will use the washer method to find the volume of rotation. Okay, so now this time we're going to, our cross-section line is still that line that goes from one end, the top end of the region, to the bottom end of the given region. Now, if you project this line, it's going to actually touch the x-axis at x. So then everything that you do must be a function of x. So let's discuss so here we're going to talk about, so when you rotate the region, this region about the line y equals k, you're going to get an object, a shape like I don't know if I graph it here. Okay, so it's not here. So you're going to get the bottom, this bottom curve will give you an object that is inside the bigger object. Okay, so you're going to have two circles or two discs. You're going to have this circle, smaller inner, we call it inner circle, and then there will be the outer circle. So then you're going to have the inner object, and then you're going to have the outer object. So the point is the volume they're asking you to do to find here is the volume that is between the two objects. So so this is where at this point X I will slice vertical slice. So I'm going to slice my object. So when I slice the object and I look at the side view from the right, I'm going to see this is going to be like an empty space there, a hole there, and you're going to see the inner circle and then the outer circle. So this image is being projected here. So the center is where you have y equals k, which is that dot there, the center of this is called washer, right? Because this space here, the inner circle, inside the inner circle here, it's all empty, and there's this inner circle, and this is the outer circle. So what we're going to do with this washer is, remember, the name of washer came from the washer, a piece of tool that you use when you fix your bike. Okay, sometimes you need the washer to kind of straighten the screw or something. So that's why we call the washer method. The washer method is used because we're using the washer, and this is the washer. So when you look at this washer, what we're going to do is find the area of the washer. So the area of the space between the inner circle and the outer circle. So this inner circle has the radius that we call inner radius, and the outer circle has also its radius, this big radius here, which we call the outer radius. So for us to find the area of this strip, the washer, you will need to take the inner circle, the outer circle, which is the bigger. You find the area of the outer circle minus the area of the inner circle is going to give you the area that is between the two circles. So the inner circle, find its area. The outer circle, find its area, and then minus the area of the inner circle, it will give you the area of the washer. Okay, so that's the idea. So when we get the area of the washer, then we can integrate the area of the washer to get the volume occupied, that is the volume of the space that is occupied by those two objects, the inner object and the outer object. So let's discuss this now. So so now for us to find the the uh, inner radius, we're looking at this circle. So we know at the center we have y equals k, and then at this point here, it's the function itself, y equals g of x. So this radius is a g of x minus k, which gives us the inner radius. So inner radius is, we write it as r sub I of x. I stands for inner. So we got the g of x minus k. When you look at the outer radius, so you still have the same center, only the top point is y equals f of x. So what you're going to do is take f of x minus k. So f of x minus k give us the outer radius. So the outer radius, we write r sub o of x, which is f of x minus k. So now we have the two radius. As I gave you the concept is to find the area of the washer. To find the area of the washer, you have to take the area of the outer circle minus the area of the inner circle. So now we go to step 2. We write down the inner radius, which is g of x minus k, and then we find so we write the outer radius, which is r sub o of x, equals to f of x minus k. So now we go to the area. We find the inner area of the disk, which give s sub I of x is pi times r sub I of x squared. But r sub I of x is g of x minus k. And then we find the area of the outer disk, which is pi times r sub 0 of x squared. R sub 0 of x, we know it's f of x minus k. So now, step 6, to find the area of the washer, we know we have to take the area, the outer area minus the inner area. So S sub W, W stands for washer, the area of the washer is therefore the outer area minus the inner area. The outer area is this minus the inner area. So now, in terms of the concept of finding the volume of rotation is, in this case, is to integrate the area of the washer from A to B. So, but the area of the washer is expressed as such. So we're going to integrate from A to B the pi times quantity f of x minus k all square minus pi times quantity g of x minus k all square, and then dx. So pi is a number, we can factor it out, and then we get this. Okay, so that's the concept. All right, so the next video is going to be about doing the example. Thank you for watching.